Good afternoon. It's great to be here. And yesterday somebody was telling me, your fourth child has been born. And
These are your slides.
no, that's not my wife. So just while they get the slides on, what it means is I've got three kids. And the history behind MDEL was happened a couple of years ago on a Teams call with some of the PIs over here. And the challenge was, how do we get an academic research institution in place, started up, to get the QMRV, which is what I'm going to be talking about today, at scale as soon as possible. This is before the Global Methane Pledge was announced, before Quad O was announced, the GHGRP updates was announced. And much of that was as a result of what I saw, or what Cheniere saw, through the QMRV program. So extremely proud, and kudos to all the MDill staff and students to putting this program together and bring it as a reality. So my name is Fiji George. I head the Climate Sustainability Programs at Cheniere. And I was initially going to talk more about the science, but some of my slides have already been presented here and provided in deep details in the posted session. So what I will switch gear is I'll try to talk about in a way as how we at Cheniere, as the largest consumer buyer of natural gas in the United States, one of the largest holders of pipeline capacity in the United States, and the second largest LNG exporter outside the state of Qatar, ties all these things together across the supply chain, and more from a corporate and a public policy standpoint. All right. So first of all, yesterday a question was asked to a chief operating officer, Corey, right? Why do this stuff, right? There are multiple reasons why, and there are regulatory drivers, there are non-regulatory drivers, and there are regulatory drivers not just in the US, but also in Europe and elsewhere. So when we look at the market, we look at ourselves as Cheniere. When you buy 8% of the natural gas consumed in the US as a company, we have a totally different view of the world. We export to 37 countries globally. So what we do is we have a lens of what's happening in the US, but also internationally. So we are proud to call ourselves as the US natural gas's largest sales force, and we occupy this unique position where we're the fulcrum between US gas supply chain and the international markets. So there's a slew of regulations coming in, and most of you guys heard about the US regulations, but also ESG is part of my portfolio at Cheniere. So there are upcoming SEC rules. You cannot have different numbers for GHGRP versus SEC versus your research program. So all of that needs to be tied in, else you'll hear from your general counsel if you're a company, and of course you'll be subject to a lot of other issues. So you've heard about the methane rules and all of that, but there are also, US has got power plant rules that are proposed that has indirect impacts to market. European rules, I know many of you have heard from Ben yesterday, Ben Cahill at CSIS. There are a slew of European rules that are coming in. I'm not just talking about the EU methane rule, but the EU ESG rules. For example, if like companies like us, we hear from EU-based investors, EU-based customers on greater disclosure of our methane footprint across the value chain. And this is because of upcoming rules in the EU. Some of them are final, like the CSRD and SFDR are final rules. Some of them are upcoming, where you as a US company will be caught because of the obligations of your EU customers, like the CSDDD. Then there are also a couple of rules that are already final, like the EU shipping rule is final, where if you are a shipping company, you have to turn in emission allowances into the EU ETS. Oh, by the way, it has also to be computed using either engineering estimates, and there's another rule, accompanying shipping rule that's going to come up, which is going to be talking about life cycle emissions. And of course, you've talked about the CBAM, or the cross-border adjustment mechanism in the EU, is up and running, so it has got indirect impacts. So there are also non-regulatory impacts or drivers. You've got Carbon Mapper. You heard Dan Cusworth over here, and EDF have publicly announced monitoring campaigns. And if you don't know whether your facility has been mapped by Carbon Mapper, I would encourage you to go to Carbon Mapper's website, and it's very likely your facility is on their database. And some of their programs are funded by NASA too. So Riley and his team at Carbon Mapper have been doing a wonderful job. They're putting a lot of data out in the public domain. So bottom line is, it's very likely as an operator, your data is in the public domain. So what's the impact of all these regulations from a corporate policy standpoint or a public policy standpoint? For Cheniere, our business model is exporting LNG, right? Our business model also depends on how it impacts gas prices, right? What's the impact of all these regulations to price formation at Henry Hub? Now, we have mapped each of our suppliers, and we do know from using GHGRP what their, or the traditional emission, conventional inventories, what their potential impacts are. However, it's pretty different when you do measurements. And so how do you get that? How do you understand from a risk management standpoint what those impacts are to price formation? So these are some of the drivers that we use and as an operator to assess going forward. So just, I'll spend 1 minute on this. So our actions, I joined Cheniere in 2018. We had a free slate to start the program over there. And we sowed a lot of programs, and we're seeing the harvest. We're harvesting the results from a lot of these programs. I'm not going to go through this. I'm going to talk about the QMRV a bit. But one thing I missed in the driver section is the financial sector. Like, so we had an ESG revolver done with some of our major lenders in 2022, where we, or 2021, where we had certain QMRV measurement drivers as part of the trigger. It was almost $1 billion revolver. So those were some of the reasons. That's another financial reason that you guys might be interested in. So move over to our first step. To understand what your emissions profiles are over the entire value chain, we spent about 2.5 years building a life cycle model. And one of the things you will find in our programs from the previous slide is most of our climate programs have collaboration with academia. So this is a program in which, this was a paper that Dave Allen, Paul Balcombe over here, and a couple of professors from Duke were involved. So we built a life cycle model. What is the difference about this life cycle model is it is very bespoke to our supply chain. Now, granted, the data that goes in is still what we call level 3 under OGMP, which is GHGRP or GHGRP plus, but the model is there. We have since then updated the model. We have about 60 plus different pathways by which the gas comes in from our producers through gathering and boosting, processing, transmission, and eventually to our plants. So we have modeled that pathway. It's very unique. I'm not going to go through the details, but bottom line over here is when you do this kind of analysis, you can assess the contribution of methane versus CO2, the contribution of how bespoke LCAs help you to understand your supply chain better, which suppliers, which supply basins are more intensive. I can tell you that we've used LCAs for corporate decisions for some of our new projects to decide what should we install at our facilities, where should we source from, what's the impact of sourcing from this basin versus that basin. So we use our LCA for corporate decision making. Now, again, it's based on engineering estimates. So the next is what we've been doing using our LC output is generating cargo emission tags. I want to emphasize this, and this is super important. This is not certified gas. We have not bought a single molecule of certified gas. These are cargo emission tags that were designed and built even before the first certified gas phenomena started over here. So what this basically tells you is basically an output of our LCA on FOB basis, which is basically intensity of the the LNG shipment from the production through the LNG terminal, or DES basis, which includes the shipping segment. So what you see on the rightmost panel is sort of a screen dot version of a cargo emission tag. What it has is what is a ship, when was it loaded, what's the CO2e intensity, what is the methane intensity, and the distribution and contribution from the different segments. This is what we've been issuing since last summer to all our long-term customers. I need to emphasize, it was never asked by our customers. It was voluntarily thought about by us as a good practice, because what we wanted to do with all our long-term customers was to provide them data so they can make informed decisions. So this has been going on, and it's been very well appreciated. Okay, so coming into QMRV. Okay, so we did this LCA. As I mentioned, the model is agnostic about measurement versus engineering estimate. And I've been in this business for about 30 years and about 15, 20 years in the methane space. And what we knew 10 years ago is different from what we know now. Heck, I would say what we knew 10 months ago is different from what we knew now. So the QMRV program was designed as an R&D program where we worked with a subset of our key suppliers. And the goal was to understand and characterize emissions, not just methane emissions, but also CO2 emissions from this portfolio of operators. So in the upstream side, we had 5 operators, 3 basins, representing about 400 million a day participated in the program. On the midstream side, we also had about 5 operators, including one of our own compressor stations, the Gillis compressor station. We also funded Paul Balcombe and shipping emissions, and I'll let him talk about that study, because that is the first measurement full campaign, and it was done under COVID conditions, and Paul can talk about his pre-boarding place where he rested for 2.5 weeks before coming into the States. So that study has been done, and liquefaction is, we are also doing actual full-scale measurements of QMRV measurements at our sites, and this has been going on for almost a year. So quickly, what is the QMRV program, and why do we think it's different from a lot of quote-unquote protocols out there? So first thing I want to emphasize is, you saw before, every one of the QMRV study has academics, 2 academic institutions at least in the program. So the protocols were designed by academics, executed by academics, and we are publishing papers led by the PIs or the students. So key things is, there is a baseline emission measurement phase where the scientific team comes out to the operator site. By the way, Cheniere enters into a legal agreement with the operator on how data is handled, the obligations of the operator to Cheniere and the scientific team. So all that is crystallized in a legal agreement between Cheniere and the operator. And similarly, there are legal agreements between the operator and the academic institution with respect to site access and so on. So the first step is they do a QMRV plan. They send it to the scientific team and Cheniere for approval. Once it's approved, the scientific team comes out, does a baseline measurement. We typically, in these studies, we've used about 5 technologies, all the way from satellites to OGI cameras. the measurements go on for a week. Data goes back to the scientific team. They analyze it, present the baseline results to the operator, discuss it, and then the next phase starts, which is the enhanced monitoring phase. Legally, the operator has to put on these technologies for at least 6 months. On a monthly basis, they have to share that data, the emissions data and the operational data, to the academic team for synthesis and analysis. There's a discussion that happens, collaboration works well between the two sites, and then the academic team comes back 6 to 9 months afterwards to do what is called the end of project. Some call it reconciliation, but an assessment of what happened. And that, again, goes for about a week using some of the same top-down technologies. And then the report's issued by the first primary academic team. And then we have something called a second team, which is the independent assessor. The role of the independent assessor is to independently assess what the first academic team did. So this is an R&D program, and it's a multi-million-dollar R&D program that was completely funded by Cheniere. And I wouldn't recommend this as the protocol going forward because it's too darn expensive. But this was purposely designed to be hard to understand what the pinch points are. What are the tough areas to knock? And we've learned a lot. So the first paper was published last year by Lira Wang, led by Lira Wang et al. And I think she spoke yesterday, so I'm not going to go through the details. The second paper was on the production side, was also published. It was led by Dorrit Hammerling's team. Will Daniels was the lead author. It focused on the full scope of the production study, but also focused on how you can use continuous monitors, and I believe Dorrit has eloquently explained, so I'm moving on. The third paper was led by Dan Zimmerle's team. Jenna Brown was the lead author, and she's in the audience somewhere. And it was about the midstream assets and measurement campaigns at compressor stations. How is it different from taking decisions or experiences from the Permian on production and assuming that could be a policy construct for the rest of the world? How wrong can that be? You know, that's the story about this paper. And by the way, last night we put into preprint the second midstream paper, and I'll briefly touch on the results today. But that's available in preprint. Again, the lead author is Jenna Brown. It's done under Dan Zimmerle's guidance. Okay, so what did we learn? Well, what we learned was we need not just one technology or a technology. We need multiple technologies. And once we can fit this together, you can have better understanding of what measurement-informed inventories are. So that is the key point from all the QMRV studies. I can tell you that that is a key point from the liquefaction study that we have not published yet. This slide, I believe, was presented by Lira yesterday. And however, the right panel, the end of project result is still under work, so you guys are getting a free preview of what the results are. So what's really important, even for production, right? You know, so we had operators in Permian, operators in Haynesville, operators in Appalachia, part of this stuff. We found emissions varying between basins. Okay, that was expected. We found emissions varying between operators in the same basin. We found emissions varying between facilities by the same operator in the same basin. So key point is this concept of developing basin averages and assuming that as gospel for everybody should be refined and rethought, especially if you're thinking about differentiated gas supplies, especially if you're thinking about methane fee and so on. If you're a good operator and doing a lot of prudent development, prudent operation and development, like some of our suppliers, you don't want to subsidize the bad actors in your basin, right? So this is a fairness issue that people should consider. The second key point is when you're developing measurement-informed inventories, especially for the production side, you need operator-specific data sets and operators' help. You cannot just remotely do this without a context of what's going on. So you need that firm support from operators to better understand the context of what's happening. And not a surprise, but this is a parity chart, right? So once the x-axis is the inventory, or what we call the operator estimated inventory, which is GHGRP plus a lot of other things. And the y-axis is Prgrm measurement. We were just comparing that. So what we're finding is between the beginning of the project and the end of the project, you can see the numbers have moved closer to the parity chart. And also the number two is you've seen the numbers generally lower. So the end of project measurements were compared to the baseline measurements, which were done roughly about 9 months prior, were on an average about 40 to 92% lower. So very small sample size, and it's too hard to say this, but one hypothesis is when operators were provided the data, synthesized and analyzed and made sense of what the data means, the operators took the right action, and therefore the numbers would have likely gone down. All right, so the next is from the paper that Jenna talked about, and you saw this graph with Dan, and it's now out in preprint. When it comes to midstream, right? And so my 15 years of my career was spent at El Paso, where back in 1999 I started doing methane emission detection when it was not in vogue, right? So we were trying to figure something out then, and I thought, hey, I knew everything with transmission, right? And Dan Zimmerly is the scientific guru on transmission, so we knew everything. So we designed a protocol, fail-proof, designed by two guys who know this stuff. I can tell you that after we did the baseline measurement, we realized that how wrong we were. We went back, worked with our operators, like Williams was part of this project, along with Kinder Morgan and others, and we revisited it. So what this slide shows, and this is from a policy guy perspective, okay? I'm not talking from a scientific perspective. Two technologies employed concurrently at the same site had numbers significantly different. So nobody's going to be signing up for two aerial technologies and say, well, I'm going to develop measurement-informed inventories. In practical sense, it's too expensive, right? But from an R&D perspective, we tried two technologies at the same site and came up with completely different. So in the baseline, statistic convergence happened for 2 out of 28 measurements. In the end of the project, where sample size increased, the difference between solution 1 and solution 2 increased to about 1,500 kilograms. So you had more samples, but the numbers varied more. So if you're an operator and if you go to your capital committee for, hey, methane fees coming in, I want to install technology X or technology Y, and when you make these decisions, which technology are you going to be using, right? It's challenging for midstream companies. So these are things that we need to take a pause and understand what's going on. And sometimes you don't have to get to fancy technologies, it can be done faster. So what we're doing with Cheniere, just quickly, we want to move towards, we're signed up with OGMP 2.0. We want to move to level 4, level 5. We're going to do measurements. Hopefully, during this process, we can improve our life cycle emissions and improve our cargo emission tax. Whether we do it, whether EU comes up with something that mandates the requirements of a certificate of origin, we'll see. But the move towards measurement is a decadal process. It's going to take time. And in that process, that is why we started, we founded MDO as the entity that could come in and help resolve a lot of these things. This is part of from our corporate responsibility chart, and you can see MDO featuring prominently as part of our corporate strategy. So I'll just quickly wrap up the conclusions. So just from a scientific corporate policy standpoint, we found a lot of variability of emissions. not a surprise. Midstream was much more complicated than what we expected. You need multi-scale technologies to address this measurement-informed inventory issue, especially as you develop empirical data sets. And the most important conclusion, and this is a shameless plug for MDO, and I can tell you that we have fantastic partners like EQT and Williams who've joined this journey together. And we at Cheniere, we strongly feel this stuff. There might be quote-unquote different protocols by different quasi-industry groups. We take no position on that. We take no position on differentiated gas. When you buy 8 BCF per day, I've got small companies to super majors supplying gas to us. What is really important is I don't want to be in the business to decipher data and say my technology is better than yours, or my protocol is better than yours, or my differentiated gas is better than yours. I want the scientific community, and if somebody wants to tell me that your gas is different, it better have an MDIL certification attached to it. So with that, I conclude. Thank you for your time.